All right, good afternoon. These are your notes for 13-4, solving absolute value inequalities. These are a lot like the linear inequalities. So we'll be using some of what we know from that on these today. Remember that if you have less than or greater than, it's an open circle when we graph. And less than or equal to or greater than or equal to is a closed circle when we graph. Other than that, you need to know that when you have a less than sign, it's an and statement. And when you have greater than, it's an or statement. And obviously those apply to less than or equal to and greater than or equal to. So let's take a look at number 1 and 2. We're going to solve them just like yesterday. So you have to isolate the absolute value expression. So for this one, we need to subtract 12. So you have x is less than 4. Now, you also have to write the second part with the negative 4. When you do that, and this is going to be an and, you have to flip the inequality sign. So x is greater than negative 4. Because it's less than and greater than, we're going to have an open circle on 4 and negative 4, and the shading is in between. Because x is less than 4, which is to the left, and greater than negative 4, so that's to the right. So when you have and statements, your shading will always be between your two dots. Okay, on number 2, we need to isolate the absolute value. So that's going to be subtract 5 from both sides. So I have x minus 1 is less than or equal to 4, and x minus 1 is greater than or equal to negative 4. Now with this one, I still have to add 1. So I kind of wrote too big here. X is less than or equal to 5, and x is greater than or equal to negative 3. Okay, so because they're less than or equal to and greater than or equal to, I need closed dots. Closed dot on the 5, closed on the negative 3, and we're going to shade in between again. Okay, and I have written here, remember, flip the inequality sign when writing the second equation. Excuse me. We're going to go on to examples 3 and 4. And this is greater than or equal to, so this is going to be an or statement this time. To isolate the absolute value, I have to subtract 4 from both sides. So I have x is greater than or equal to 1, or x is less than or equal to negative 1. So these will be closed circles on the 1 and the negative 1, and the arrow goes to the outside. Okay. And then for number 4, to isolate the absolute value, I have to divide by 2. So I have x plus 2 is greater than 3, or x plus 2 is less than negative 3. So to get x by itself, I need to subtract 2. So x is greater than 1, or x is less than negative 5. Because it's greater than and less than, my circles need to be open. So I have an open circle on the 1 and open circle on -5, and the arrow goes to the outside. All right. I'm going to do an example of a word problem with you. It is on page 488. Your turn number 11 is the one that we're going to do. Let me book open here. And it says a box of cereal is supposed to weigh 13.8 ounces, but it's acceptable for the weight to vary as much as 0.1 ounces. Write and solve an absolute value inequality to find the range of acceptable weights. So you're going to take what it could vary. What it does weigh has to be less than or equal to 0.1 ounce. Because it could be greater than, or it could be negative or positive, is where the absolute value inequality happens. So we take what the cereal weighs and subtract the 13.8 from it will give us how much over or under the box is, and that has to be less than or equal to 0.1. Okay, and in this one, the absolute value inequality is already isolated. So I'm going to write it as two statements. So you have W minus 13.8 is less than or equal to 0.01, and W minus 13.8 is greater than or equal to negative 0.1. So I need to add 13.8. to everything. So I have W is less than or equal to 13.9, and W is greater than or equal to 13.7. If you recall from when we did linear, we write and statements doing smaller number is less than X is less than the larger number, which is the format we would like your answers written in. So I'm going to say that 13.7 is less than or equal to X is less than or equal to 13.9, and that's going to be my final answer. Okay, the other thing that you need to know to do your homework tonight is that when you have an absolute value, that's ABS stands for absolute value. That's actually the calculator shorthand for it. So when the absolute value is greater than a negative number, you get all real numbers. And when an absolute value is less than a negative number, you have no solution. Okay, you'll need to use those for tonight's homework. The homework for this lesson is 13.4. It's page 490 to 491, numbers 11 through 21 all. Have a great afternoon.